So now we're going to learn about the cross product, and we're going to calculate the cross product of two given vectors, use determinants to calculate a cross product, find a vector orthogonal to two given vectors, determine areas and volumes by using the cross product, and calculate the torque of a given force and position vector. So before we go into the cross product, I just want to do a very quick review of the dot product, okay? So let's just do a quick review. Of the dot product. Okay, so, and the reason why I do this is because when you introduce one without quite remembering the other, you can't see the difference and you get confused. So let's be given vector u, and u is going to be u1, u2, u3, and a vector v, and v is going to be v1, v2, v3. And so the dot product, u dot v, now notice u and v are vectors. The dot product says take u1 multiplied by v1, take u2 multiplied by v2, and take u3 and multiply by v3. So when you're done, you have this combination of scalars. This thing is an element of R. It is a real number. It is a scalar. Okay. It does not have dimension. I'm sorry, it does not have direction. There's no direction to it. It is not a vector. Okay. So now we want to talk about the cross product. Okay, so again, I'm going to take these same two vectors. So we have these same two vectors. So now A cross B, sorry, U cross V is going to be the vector that has components U2 V3 minus U3 V2 I plus U3 V1 minus U1 V3 J plus U1 V2 minus, yes, that's right, U2 V1 K. And you're saying, why in the world would I have to memorize that? So I'm going to write it the other way as U2 V3 minus U3 V2. That's the first component. U3 V1 minus U1 V3, second component, and U1 V2 minus U2 V1, third component. Okay, so the way I remember the dot product is, let's draw a triangle. Okay, so here is U1 and V1, U2, and actually U1, U2, and U3. All right, so so the first component, which is the I component, takes U2 and V3. And so now I'm going to, so if I'm trying to find the first component, I use 2 and 3. Okay, but it travels like this. So if I'm trying to find the first component up here, number 1, I'm going to use U2 and V3 and V2 and U3. If I'm trying to find the second component here, I'm going to use U3 and V1 and then the opposite. And if I'm trying to find the third component, I'm using 1 and then 2. Okay, so that's so for 1, notice 1 and then 2, 3, 2, and then 3, 1. So it's like a circle. 2, 3, 1. So here's my circle, 1, 2, 3, and I'm always going in this direction. So I should have made it in clockwise. I never thought about making it clockwise, but that might help too. So that's the formula. I'm going to show you an easy way to do it. Okay. And so it's also called the vector product. So this is called the vector product because it's a vector. Then the dot product is also called the scalar product. Because it's a scalar. Okay. All right, so theorem. The vector product U cross V is perpendicular to U and at the same time perpendicular to V. So it's perpendicular to both of them. Okay, so if it's perpendicular, that means that if I take U and dot it with U cross V, I would get 0. And if I take V and dot it with U cross V, I will also get 0. Okay, so it's easy to show. I'll start it off. So we already know what U cross V is. So let's say, so U dotted with U cross V says take the first component of U, which is U1, and then multiply that by the first component of U cross V, which is U2 V3 minus V3 U2. And then we're going to take the second component of U and multiply it. This should be rounded. Multiply it by the second component of U cross V, which is U3 V1 minus U1 V3. And then I'm going to take the last component, which is U3, and multiply it by the last component, which is U1 V2 minus U2 V1. Okay, so now let's see. I have U1 U2 V3. So that's this term. And then I'm subtracting it off. So here is U2 times U1 V3. So there it is, that gets going. And then I have U1 V3 U2. So that's U1, I'm going to add it on, V3 U2. So here it is. And then obviously the last one is something's wrong. That purple one doesn't go with that one. That purple one goes with this one. Right. And then these two go together. And so you just get 0. Okay. All right, so let's recall for a moment. With the dot product, from the dot product, we got A dot B is equal to, I'll just use U and V, so since I'm on a U and V kick right now. U dot V is going to be the length of U times the length of V times the cosine of the angle between them. Okay, so now from the cross product, so now from the cross product, we're going to get A U cross V is going to be, this is a vector. So it's a vector. So now we're going to get the length of U, that's a scalar, times the length of V, that's a scalar, times the sine of the angle between them, times a normal vector in that direction. Okay? So it is a vector. So I want to draw this thing. Okay. So, oh, so here's my vector A. And here's my vector B. Or U, so this is U, and this is V, and then this is theta. And that is going to give a vector that is perpendicular to both of them. In that direction. Okay. So now I want to show that the length of A cross B is the area of a parallelogram. Okay. So here is, let's go to my axis here. And I'm going to draw a parallelogram. Okay. So on this parallelogram, this is going to be a vector here, like this. And then I'm going to draw another vector. Okay. So now the base, oh, I don't need it to be that long. Okay, so these are the two vectors. And then I want to draw a height h. So this height is h. So now from this, I can see that the area of this parallelogram well, that is the length, that is the base times the height. But the base is equal to the length. So let's call this one A, U. I don't want to use, let's go back and make life easier and make this U cross V. Okay, so now the base is going to be U, and this side vector is V. Okay, so I have two vectors and they make up a parallelogram. So the length of the base is the length of U. So however long U is, that's the length of the base. But H, so if I look at this now and I put theta in here, I have H over V is the sine of theta. So I know that H over the length of V is the sine of theta. So therefore H is the length of V times the sine of theta. So therefore, the area of the parallelogram which is base times height, is the base, the length of u, times the height, which is the length of v, times the sine of theta. But this value right here is scalar. And it is the length. So now if I put the vector there, if I put the vector next to it, it would be the vector u cross v. But because it's a scalar, I need that it's only the length of that. So therefore, the length of A cross B is the area of a parallelogram. Okay, so now what happens if you do V cross U instead of U cross V? So what happens? When we commute, excuse me, U cross V and calculate V cross U. Okay, so this is the right-hand rule. Okay, so I was showing you the right-hand rule way back when we first started doing the 3 dimensions. Okay, so I cross J gives you K, so it's a right-handed rule. So when you do, so the right-handed rule, let me see if I can draw this monster. Okay, so when I do U cross V, so I do U cross V is going to give me a vector that's going to be perpendicular to both of them in this direction. So that vector is perpendicular to U and it is perpendicular to V. So this is U and this is V. I get this vector U cross V. But now if I do V cross U goes in the other direction. Because remember, this is the right-handed rule. So the right-handed rule is we're going in the direction of one vector crossing the other vector. And so now if I do the same thing, it's not going to look exactly the same because I'm struggling. So now I'm going to take and do my vector U. And my vector V. But this time I do V cross U. Then the vector is going to be perpendicular, is going to be down here. So this is minus U cross V, which is V cross U. Okay. So we get that V cross U is the opposite of U cross V. So if it asks for U cross V and you put V first, your answer is going to be wrong. Okay. So I cross J is K. J cross K is I. And K cross I is J. But don't switch them. Okay. Now, the other thing is if I take I and cross it with itself, I'm going to get 0. If I take J and cross it with itself, I'm going to get 0. And if I take K and cross it with itself, I'm going to get 0. Okay, so let's do some cross product properties. What's today, Wednesday? Yeah. Okay, so we have the first one. Now the cross product has more rules and they are more difficult than the dot product rules. Okay. So the cross product rules are the scalar distributive law. And that one says, so here I'm going to let U, V, and W all be vectors in R3. And I'm going to let R and S be scalars. Okay, so the first one is if I take R times U and cross that with S times V, I can pull the R and S out, multiply them first, and then get U cross V. So if I have a scalar multiplied by the cross product, it just comes out front. Okay, to the vector distributive laws. And it's 2 of them. So if I take the vector A and I cross it with the vector B plus C, that is the same as doing A cross B and then adding that to A cross C. Okay. And if I take B plus C cross A, that is B cross A, plus C cross A. Okay. The third rule, I'm not sure what the name is. I think it is the distributive property, another distributive property, A, dotted with now B cross C. Now this should make you think, because now I have a vector dotted with a vector, so the result should be a scalar. And because the dot product, this is actually really strange. This comes out to be the same as A cross B dot C. So they don't change order, but they do change operation. Okay. This is the one that, remember I told, now I keep trying to tell you, I took this course in 1984. I had just crossed, and I took this course in 1984. And I was like, what are all these rules? I'll never be able to remember these. A cross B cross C. So now here, this is a vector dot a vector. So this is a scalar quantity. Whereas this is a vector cross a vector. And when you cross vectors, you get back a vector. So this is going to be a vector quantity. So this is A dot C A dot C times the vector B minus A dot B times the vector C. So this is now a vector quantity. Okay. Number 5. Oh, this one's easy. If I have minus the vector A and I cross it with the vector B, that is the same as if I took the vector A and crossed it with minus B. But that's also the same as if I took negative A cross B but this is the same as B cross A. This is also a vector quantity. Okay. All right, so now let's do the determinant formula for finding cross products. Do you know how to take a determinant?
Determinant from like algebra?
What'd you say?
I said determinant from algebra.
Yes.
Isn't it b plus or minus the square root of 4? Well, that's
okay. That's the discriminant.
Oh, determinant. Oh
no. Okay. Did you take linear yet?
No, I took it next semester.
Okay. Well, when you're gonna learn the determinant, and then you will know it when you get the linear. Okay, so let's do determinants. Yeah, the discriminant and the determinant do sound the same. Okay, so let's do first a 2 by 2. formula. Okay, so if I have a matrix and my matrix holds 4 elements. Okay, so this is a matrix and it can hold 4 elements, whatever, and they're all real numbers. Then let me call this matrix A. Then the determinant of the matrix A is written with straight lines. And it is A, B, C, D. That's the notation. And it is written to be A times B minus C, A times D, oh gosh. A times D minus C times B. So it's actually rather easy. So for example, if A is equal to 4, 1, 3, 2, then the determinant of A says take these two, multiply them, then subtract these two. So that's going to be 4 times 2 minus 3 times 1, which is 5. So the determinant of that matrix is 5. If B is equal to the matrix 3, 1/2 minus 2, 1/3, then the determinant of B is going to be 3 times 1/3 minus a negative 2 times 1/2. So that's 1 minus a negative 1. So that's 2. So the determinant of a 2 by 2 matrix is very, very, very easy to calculate. Okay. So now if C is equal to U1, U2, V1, V2, then the determinant of C becomes U1, V2 minus U2, V1. Okay, so that is the determinant of that matrix. Okay, so now I want to take the determinant of a 3 by 3. So do you understand the 2 by 2 formula?
Yes.
Okay. Because the 3 by 3 formula is more difficult. So the 3 by 3 formula, I'm going to take and I'm just going to start off with the determinant. So what's inside is C1, C2. Actually, let's use U's and V's. So W1, W2, W3, U1, U2, U3, and V1, V2, V3. Okay. So when I take the determinant of this, I have to find little subdeterminants. Okay, so the determinant of that says take the first number U1, I'm sorry, W1. So I'm going to take W1. And then I am going to cross off who said I wanted you there? So then I am going to cross off the first row that contains W1 and the first column that contains W1. And it leaves this little tiny submatrix right here. Then I'm going to subtract, it alternates, W2. So W2 and then I'm going to take I don't know why you come up where I don't want you. Sorry, I'll move you. So this time I'm going to cross off the W2 row and the W2 column. And now I get this guy and this guy. And then I'm going to add on the last piece, which is W3. And then one last time to place this determinant where I want it to go. It still just goes where it wants to. So this time I'm going to cross off the row that W3 is in and the column W3 is in and take what's left. Okay, so I know that's crazy, but this is what it looks like. So the actual determinant, please be there. Okay, that's fine. That's good enough. So that's going to equal W1 times the determinant of the U2, U2, U3, V2, V3 minus W2 times the determinant of U1, U3, V1, V3 plus W3 times the determinant of U1, U2, V1, V2. So that comes out to be W1 times U2, V3 minus U3, V2 minus W2 times U1, V3 minus U3, V1 plus W3 times U1, V2 minus U2, V1. So it looks a little bit crazy, but that's what it is. Okay. I have 4 minutes left. I'm not going to finish. So if I put I up here, J up here, and K here, and I put U1, U2, U3. So notice the U vector is first, and the V vector is second. By following the same thing, where I have W1, I'm actually going to have I. So this is going to be U2 V3 minus U3 V2, but it's going to be times I, the first thing, minus, then I'm going to get U1 V3 minus U3 V1. Instead of W2, I have J. And then I'm going to get U1 V2 minus U2 V1. Instead of W3, I have K. And this big old long formula that is U cross V. Okay. So say U is 2 minus 1, 3, and V is equal to 4, 1, negative 2. And those are two vectors. Now I can find the dot product easy, but the cross product, I'm going to take this. I'm going to have I, J, K. U comes first, negative 1, 3. V comes second, 4, 1, negative 2. So if you remember, I'm going to take I, so I know I'm going to have I have I, and I'm going to cross off the first row and the first column. So that only gives me this little tiny thing down here, which is minus 1, 3, 1, 2. So I get the determinant of minus 1, 3, 1, 2. But whatever that number comes out to be, I multiply it by I. Then I tried not to do this. Okay, for the second one, I'm going to get rid of the J column. And that leaves 2, 3, 4, and negative 2. And then when I cross off the K column and K row, I get 2, negative 1, 4, 1. Times K. Okay, this is easy. -2 minus 3 is -5, minus -4 minus 12 is -16, so it becomes +16J. And then 2 minus a -4 becomes 6K. All done. And we will pick up here tomorrow.
Okay, see you tomorrow.
Okay, see you tomorrow.